in looking at our irregularly truncated rectangular prism, we calculate the vectors along the top, PQ, QR, RS, and SP, to move around counterclockwise. And then we want to calculate the cross product, QR cross PQ, the later one, QR cross PQ, which gives us a vector in this direction. And then PQ cross SP, PQ cross SP, again a vector in this direction. If this thing is truncated by a plane, then these vectors are going to be identical, as will these vectors. If not, then we need to make a comparison to see how close they are, to get some idea how this thing might be curving. Okay, so we got QR cross PQ. It's perpendicular to PQ and QR. We're just making a statement. PQ cross SP is perpendicular to PQ and SP. Question is, are QR cross PQ and PQ cross SP, this cross this vector, and this cross this vector, are they parallel? So we can answer by the dot product, by the cross product, or by finding a unit normal vector for each. Find the unit normal vectors. And one would be PQ cross QR divided by the two magnitudes, product of the two magnitudes. And you know, I wrote that and it's actually wrong, but what you're doing is okay. Should have been this vector divided by its magnitude. Now if the angle, well, it's got an angle of 90, excuse me, if the angle of the vector itself is 90 degrees, it really doesn't matter. We're going to write it this way. Okay, so anyhow, that's a calculation. Then we can compare these two unit normal vectors, which ought to be up to the accuracy of our measurements, equal if the thing is truncated by a plane. If not, then they're not going to be quite equal. And whether they're equal within the uncertainty of our measurement or not, well, that's what we're trying to determine here. So, mainly an exercise in getting an intuitive feel for the cross product and the use of the dot product and so forth.